What's up, guys? Hey, Devs here. And another day of LeetCode. And yesterday was the 100 subscriber special. We can go ahead and check out the channel. I haven't checked it since yesterday. 126 subscribers. That's big news. The 100 subscriber special got 84 views, but it is a longer video. I did kind of rush it because I was kind of busy. I think the sweet spot's between 10 and 20 minutes. That's about where I get the most views from. Or if my friends get flamed in the comments, like in day 5, then it's 700 views. Poor Taylor. He was, the only hate comments I've gotten is from my friends, which I think is hilarious. W fan base, by the way, because they were defending my life tooth and nail in the comments. I had to explain that those are my idiot friends and not to mind them. Girlfriend's on the couch, my beautiful soon-to-be wife, hopefully, and then we have Buster Bob. I don't know if you can see him playing. I'll pick up the map. He is right there. Bro's living his best life, so he might pick up a squeaky toy, and I apologize for that noise. But we're not doing the same tree we did that one yesterday. We're doing the path sum problem. It is an easy problem. I wanted to lay it back a little bit. I am trying to get off of here and watch a movie and get in bed soon. So the path sum is given the root of a binary tree and integer target sum. Return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. So we want to make sure we reach the target sum and that it's a leaf node before we return true all the way back up. And we're given a few test cases, like none of them equal up to, what's the target? Yeah, target's 22, 5 plus 8 is 13, 13 plus 13 is 26, so that don't work. 13 plus 4, that's 17, and then 18. So none of them have a target we need. Target sum of 5, 2, and 3 equal up to 5, but there's no way from the root to find a path down there. So I didn't think this one was too bad. It did take me a little bit to find the problem. So I have my solution up here. We're going to basically be copying it, and I'm going to try to explain what I'm doing. So the first thing we want to see is if root is equal to null. Because if we're at a null node, then we know we've made it past the leaf, and we want to return false for this. Or if we're past a null root, then we know the target sum isn't. We can't get the target sum, so we know that that's also going to be false. So the next thing we do is we get a new target. And I set this equal to target sum minus root.val. So the reason we can do this is because root.val will never call on a null root because we already checked if it's null, right? And then from the new target, if you imagine in the first example, we get the target of 22. We know that this value, 22 minus 5, will give us 17. So the sum from 5, we want to check each node passed with the target sum of 17. So this is another recursive problem. Binary trees are great with recursive problems. And then we'll check these subtractions all the way down the tree. So 17 minus 4, that would give us 13. 13 minus 11 will give us 2. And then we check down each node again. 2 minus 7 would give us 2 minus 7 would give us -5, and then 2 minus 2 would give us 0. So if we get if our new target is ever equal to 0, and we want to make sure that it is a leaf node. I don't think y'all can see this because of the webcam. Oh yeah, I'm blocking this completely. So once we get down here where the new target's 13, or it gets past 13 from 4, and then 11 minus that would give us 2. So the target sum is 2 into both of these, and then the new target for both these function calls would be -5, then 0. So if a new target is ever equal to 0, and it is a leaf node, then we know we have found a I'm going blank here. We know that we have found our solution, and we can return true all the way up the tree. So if the root is ever equal to null, we want to return false. Other than that, we want to find the new target. Then once we have the new target, let me pull up my other solution. Once we have the new target, we want to see if the new target is equal to 0. And we want to make sure it's a leaf, right? And the way you see if it's a leaf is if root dot left is equal to null, and root dot right is equal to null. So it's a leaf if it has no children, and then if it has no children, then it points to nothing, right? And then we can return true here. So this would be the only case we would ever return true. And if we ever make it to a leaf and return false, then we know it's false. Or if we make it past a leaf, then we know that we haven't found our target sum, and we return false. And then other, we would return as path sum, and we're going to pass it the root left, and then we're going to pass it the new target. And then we want to see, we want to OR it as path sum, right, and then new target. So this will check down every leaf, to every leaf, finding the new target and subtracting each value along the way. And if we ever get to a leaf and it equals 0, and it's a leaf, then it will return true. You also can't see this again. But you're getting feisty over there, huh? He's growling a little bit. So if we ever get to a leaf and it equals 0, our new target, then we know we have found a valid solution, and we can return true all the way up. And because it's ORed, it's returning an OR value all the way up to the tree. You can imagine it's like this. So this is true, this is false. Once again, you can't see that. Let me make sure y'all can see this one. Yeah. So this value is going to return true because it equals 0 and it's a leaf node. This one, it will check both of the nodes under it, and it will say that they're null. So it will return false, and it will return false. And then 7 is returning this section right here. 7 is returning this. So its left and right are both returning false. So then 7 in turn will return false. And then 11, also called the has path sum to its left and right node, but it's ORed. So false or true is true. And then 4 also has a null here. So this one is returning false. And then true or false will return true. And then down here, you can imagine the same. It checks every leaf node or past the leaf node. And all of these will return false. And it will make its way up. So then false or false is false. And then false or false is false. And then false or false is false. False or false is false. And then finally, we'll get to the very top, where 5 initially called the first recursive call, and it returned left and right. of the has path sum. And this one will have the true value, this one will have the false value, and then it's going to be return true or false. And then finally we get return true like we wanted. And this should work for every case. For the test cases we have down below, I have an extra case because this was originally where it failed. And the reason it failed is because even though I said it like if target sum is equal to 0, I said if target sum was greater than 0, call it recursively, and then if target new target is equal to 0, then it will return true. But that's not the case because 2's leaf node is, you can see in the test cases, it actually draws out the trees. 2's test case, we're looking for 12, and then 12 minus 10 is 2, and then 2 minus 2 is 0, but this isn't a leaf node, so it wouldn't return true. So then I added the case where it would check if it's a leaf node, and then in that case it still didn't return true because it never called recursively for the 0, and 0 minus 0 is 0, so this is a valid path. But this solution solves that, and it also works for negative numbers. That was the next problem I ran into. But if we go ahead and submit this, we can see that it runs in 0 milliseconds. It beats 100%. It has a time complexity of n, where this will run for n nodes, and it also has a space complexity of n, where this function gets called n times on the stack. And I don't think it was a bad solution. I think we ended up coming to the optimized solution. I mean, it beats 100% of cases. But yeah, so if you have any questions or comments, y'all can go ahead and leave them below. Be sure to like and subscribe. I'm about to get off here and watch a movie, and probably get a little drinky poo and drink a little bit. But y'all stay blessed. Y'all stay healthy. Be sure to keep coding, and I will catch y'all in the next video. Hey Devs is out.